Hi there! Today we're going to learn how to identify equivalent ratios. Ratios are used to compare quantities to one another. For example, when you are baking, you might use the ratio of one ingredient to another to increase or decrease the recipe size. Equivalent ratios are ratios that have the same value. Let's look at our ingredients here. If one batch of cookies uses 2 eggs and 1 cup of flour, the ratio of the number of eggs to cups of flour is 2 to 1. For 2 batches of cookies, we double the ingredients. So we would need 4 eggs and 2 cups of flour. That's a ratio of 4 to 2. So 4 to 2 and 2 to 1 are equivalent ratios. Cool! Now let's practice identifying equivalent ratios. Here is our first example. Are the ratios 1 to 3 and 5 to 10 equivalent? To find out, we will begin with the first ratio, 1 to 3, and see if we can count up to the second ratio, 5 to 10. Let's use a double number line to help us. Each number line represents part of the ratio. Let's put 1 on the top number line and 3 on the bottom number line to represent the ratio 1 to 3. We see that the top number line will count up by 1s, and the bottom number line will count up by 3s. Let's keep filling in the numbers to find equivalent ratios. 1 plus 1 is 2, and 3 plus 3 is 6. So next we have 2 on the top and 6 on the bottom. That means 2 to 6 is equivalent to 1 to 3. After that comes 3 to 9 and 4 to 12. Finally, we have 5 to 15. We want to know if 1 to 3 is equivalent to 5 to 10, so we will stop here, since we have 5 as the first part of our ratio. We see that 1 to 3 is equivalent to 5 to 15. This is not the same as 5 to 10, so 1 to 3 and 5 to 10 are not equivalent. Let's keep going. Are the ratios 4 to 5 and 16 to 20 equivalent? We can use a double number line again. Our first ratio is 4 to 5, so let's put 4 on the first number line and 5 on the second number line. This time, we will count up by 4s on the top number line and count up by 5s on the bottom number line. So we have 8 to 10, 12 to 15, and 16 to 20. Since 16 to 20 is on our number line, this shows that 4 to 5 and 16 to 20 are equivalent. This double number line can also help us see how to use multiplication to make equivalent ratios. If we start with 4 to 5, that is 1 copy of the ratio. When we double the values in the ratio, we get 8 to 10. If we triple the values in the ratio, we get 12 to 15. And if we quadruple the values in the ratio, we get 16 to 20. These ratios are all equivalent to 4 to 5. Nice! Let's try one more. Which of the following ratios are equivalent to 3 to 1? 24 to 8, 21 to 7, or 15 to 4? Let's compare the ratios one at a time. First we have 3 to 1 and 24 to 8. Let's try comparing them another way. We know that multiplying both parts of a ratio by the same number creates an equivalent ratio. So let's check if we can multiply both parts of 3 to 1 by the same number to get 24 to 8. 3 times what number equals 24? 8. And 1 times what number equals 8? Also 8. Since we can multiply both parts of the first ratio by the same number to get the second ratio, these ratios are equivalent. Let's try the next one. We're comparing 3 to 1 and 21 to 7. 3 times 7 equals 21, and 1 times 7 equals 7. We multiplied both parts of the ratio 3 to 1 by 7 to get the ratio 21 to 7. These ratios are equivalent too. Now we're comparing 3 to 1 and 15 to 4. 3 times 5 is 15. What number can we multiply 1 by to equal 4? 4! We multiplied the parts of 3 to 1 by different numbers to get 15 to 4. That means these ratios are not equivalent. So we found 2 ratios equivalent to 3 to 1. Great! Now you're ready to identify equivalent ratios on your own. You've got this.